Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Sabari Amtis Suaib. So, me and my group members will be presenting about our PBL project, which is 5G antenna design. Our group member consists of Ainur Afrina, Muhammad Syami, and me, Nur Sabari Amtis Suaib.
With the introduction of the fifth generation mobile network rapidly approaching, technological development is ramping up. New applications will arise in the automotive, healthcare, industrial, and gaming industry. This is largely owing to the new 5G standards. Another 5G innovation will be the utilization of massive MIMO antenna arrays to segregate the users, beamforming, and spatial multiplexing. Because of the increased propagation losses at these frequencies, larger gate antennas at base station and mobile terminal will be necessary to enable millimeter wavelength communication. While multi-element antenna arrays may do this, it comes to the expense of increased design complexity, narrower beamwidth, and more sophisticated feeding circuit. An antenna is essential for communication system because it determines the design of the air interface. With the gross wireless generations, technology and network capabilities provided by manufacturer, the antenna design community has also shown significant technology improvement to meet the ever increasing customer needs. Mobile communication is regarded one of the most key development of the previous several decades, having a played key impact on the country's social and economic growth. Data traffic increased dramatically as a result of fast increase in connected devices. As shown in figure below, the 5G technology is defined by its specification requirements. 5G network can be faster since they are using a shorter frequency, which is the millimeter waves between 30 GHz and 300 GHz. It can function in both lower frequency bands. In 5G technology, low density parity check (LDPC) codes are utilized as a forward error correcting code to achieve the low latency. One of the pivotal parts of the 5G device is an antenna which is required to work at an enhanced gain bandwidth and lesser radiation losses. So antenna design for 5G devices becomes very crucial while maintaining the above mentioned parameters for 5G communication. Figure above illustrate an essential way of categorization based on the antenna types. According to the literature, the following antenna types are appropriate for the 5G application. First is the monopole antenna, a straight line of length whereas the wavelength of the antenna resonance are working frequency. Several modifications were presented in the literature that modify the fundamental structure into various forms such as the conical, spiral, and others depending on the use and need. Second is the dipole antenna. It is made of two straight microstrip lines of length each, with the feeding given between the two microstrip lines. As a result, the overall length of the dipole is a wavelength and half wavelength. Third is the magnetoelectric (ME) dipole antenna. A planar electric dipole and a parabolically shorted planar magnetic dipole comprises this antenna. The magnetic dipole receives its feeding from the substrate bottom side. What is the loop antenna? This is a ring that can circular, rectangular, square, or any other shape. The loop antenna radius is lower than its wavelength. The last one is the antipodal Vivaldi antenna. It is made up from two conductors that are mirror image of each other on both sides of the substrate. The upper conductor serves as the radiator while the bottom conductor serves as the ground. Microwave is a wireless communication technique that employs high-frequency radio wave beams to enable high-speed wireless connection capable of sending and receiving speech, video, and data transformation. Microwave connections are widely used for point-to-point communication due to their short wavelength, which allows them to be aimed in narrow beams directly at the receiving antenna. This allows microwave devices to use the same frequency without interfering with one another. As a lower frequency radio wave though, another advantage is that because it is high frequency, the microwave band has a large information carrying capacity. The microwave band has a bandwidth 30 times that of the rest of the radio spectrum below it.
So for propagation study, which is microwave link, Microwave films utilizing radio waves in the microwave frequency range as is indispensable components in modern communication system. With a broadband nature enabling high-speed data transmission and cost-effectiveness due to the absence of intermediate equipment, microwave links offer a reliable alternative to traditional cable connections. Despite their efficiency, successful deployment requires careful engineering considerations for clear paths between antennas and awareness of atmospheric conditions impacting signal strength. In essence, microwave links stands as crucial building blocks in the global communications infrastructure, providing flexible and efficient solutions for diverse communication needs. So you can see that this is the datasheet for the antenna characteristics. We have the dielectric constant for 0.4. The loss tangent is 2.479 and 2.919. The thickness is 1.6 millimeter. The operating frequency is 2.4 Hz. The length is 29.44 millimeter. The width is 36.04 millimeter. The cut width is 4.28 millimeter. The cut depth is 10 millimeter. The path length is 25.357 millimeter. And last but not least, the width of feed is 2.8 millimeter. This is the antenna parameters that we have made in the software, which is the dielectric constant and the height, as I mentioned in the previous slide, which is 4.4 and 1.6. For the resonant frequency is 2.4 GHz, and this is the length, which is 29.44, and the width is 38.03. The input impedance is 243 ohm.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shahmi. So today I will present about HFF stimulation. The first one is antenna design. This is a design of antenna from using the software. The design of a microstrip patch antenna follows systematic and well-defined process. In the initial substrate selection phase, careful attention given to selecting the dielectric material based on its inherent properties to achieve desired electrical characteristics. Next, subsequent stages involve determining the dimension of the patch, including its length, width, and shape, to ensure resonance of the target frequency. The third stage focuses on the feeding mechanism, a critical component that involves selecting an appropriate technique. Example: coaxial feed on microstrip length, and surgically placing it on the patch for optimal outcomes. This is a first result, resonating area. As you can see, at the M1 at the bottom of the graph, the X value is 2.22 and the Y value is negative 34.8436 dB. Okay, next is this is the radiation plot. As you can see, the plot is here. Next is this is a radiation plot at the antenna design. As you can see, it at the bottom of the antenna plot, right there. And this is the radiation field at the antenna design. As you can see, the blue arrow is the radiation. Next is this is radiation plot field. As you can see, the plot, and this is the H-plane result that we plot. And the last result is the maximum gain in dB. As you can see at the top of the graph, M1, and what's the X 2.2 GHz, and the Y is 2.2911. Next is result and discussion. Through exploration of such as accumulation result, unitary fluorescent impedance matching, and detailed analysis are S parameters. The next is impedance matching instrument ensure effective conformity within the system. Next is a subsequent certainty of radiation pattern and gain characteristic of to understand antenna directly and spectral coverage. Next is simulation methodology involves meticulous configuration of SPSS parameter, providing a rigorous and systematic approach to design and simulation. This structural methodology set the stage for the successful construction of high-performing microstrip patch antenna. Exploration of pending property ensure compliance with specific communication system requirements. Lastly is presentation and discussion of simulation results offer a comprehensive understanding of antenna performance capability aspects like gain, bandwidth, radiation pattern, and impedance matching. Lastly is as a conclusion, through analysis and simulation of microstrip patch antenna design using HFSS. That is, results showcase effectiveness in overall efficiency, attenuation, and radiation characteristics. That is, finding will get the final construction of the antenna for practical application. That is, future development possibilities include additional antenna design, manufacturing, and optimization for experimental testing. And the next is investigation of integrating multiply antennas for MIMO on diversity application is also considered. That's all, thank you. Okay, this is our reference. The first one is XYD. Next is Ifat Naqvi, Ash and Hussein. Next is Kumar, Sumit and Denit, Amruta and Malaka, Rajeshwari and Paul, Emma and Shivada and Laxmika. The next is from Microwave Link Technology. That's all from us. Thank you.